I hope the tests went okay. I hope there's no surprises. I don't try to make tests hard or easy, just fair. So if it seemed roughly fair to you, then it was on target. So I'm definitely gonna get them back to you before reading week starts. So that means sometime next week. If I'm really on the ball this weekend and well behaved, I'll get them to you on Monday of next week. Probably Wednesday of next week. So yeah, so sometime next week I will be handing them back in class. Which means we're ready to move on to the next thing in the course, which is the short essays. So if you recall, you've got basically, I think there's just 4 elements to this course. There's a short essay, a long essay at the end, the midterm that you already did, and the exam. So here's the next thing, short essays. They are short. They're not like enormous essays, from somewhere between 1,000 and 1,500 words. You'll submit them on Blackboard. I think they're due February 24th, so something like 3 weeks from now. Pardon me. So sources other than the course materials are not strictly required. So these aren't like research essays. I'm not going to get you to like go out and do a whole bunch of research on this stuff, but you're welcome to use them if you want. So it shows me that you've been thinking about this stuff. Really all I'm going to evaluate these things on are, do you demonstrate 2 things? Understanding of the course material and thinking of your own. I'm looking for both of those things in all of these essays. It's roughly 50-50 marks for show me that you've been absorbing what's been going on in class and in the readings, and then show me that you've got something to say about it. So that's it's a really rough rubric, but roughly that. So if you look on Blackboard now, there's 3 kind of passages from various readings. You'll pick one of them, and with each passage, there's some sort of guiding questions that I'd like you to address in your short essays. So just to be clear, and I always get 1 or 2, it's expected that you haven't just read the passage, but in fact that you've read the whole reading that the passage is in, and maybe even all of the readings from the class. I know that's a lot, but maybe even having done all the readings would be good. But if you're doing a paper on one of the passages and you're not showing awareness of what happened in the rest of the paper, that's bad. That's bad. So a general awareness of what the paper is about, what it's going on about, the points that it makes, and focusing on that passage, and more specifically focusing on the questions that come right after the passage. Yeah? Okay, so I won't go through all those passages right now. Take a look on Blackboard, pick one, read the reading, think about the questions. Yeah, and I already said this, each question you're expected to provide your own original thoughts on the subject, not just repeating things said in class. When I'm reading philosophy, and it's literally my job to read and write about philosophy, it takes me 2 or 3 times going through something to really get it. Like I go through once to just get the idea. I might go through a second time with a something of an agenda. So if you've read the passage, if you've read the relevant reading once, that's really good. We talked about it in class, hopefully. If you then go read the questions associated with it, and then read the whole thing again, with the questions kind of in the background. And then when you're writing it, you might go back to specific parts of the paper and read it even again. And then that's how I read philosophy. Reading philosophy is slow. It's laborious, like it's a different kind of reading than any of the other reading that I do. So if you find yourself thinking, man, I'm really reading this slowly and I have to go over it a bunch of times, that means you're doing it the way that philosophers do it. That doesn't mean you're doing it wrong, that means you're doing it right. Yeah? Philosophers in the room, can you confirm that that's how you read super slowly and over again? Okay, yeah. 6 times for Kant? That's good numbers for Kant. Sorry.
Sometimes you'll start your paper after reading it once and you'll have this whole thing that you want to do, but then when you go to look for quotes, reading it the second time, you'll realize that you were wrong in your first interpretation.
Yeah.
So,
yeah.
Fun times.
So this is just kind of how the discipline goes, and I really do think it's different than reading other stuff. So when I'm reading history, I just read. You just go, go, go. I'm like 1 page per minute. Philosophy, I'm like 1 page every 5 minutes. I have to read it a bunch. So, and I'm like, I don't want to claim that I'm like great at this stuff, but I do it for a living. So I'm obviously not like terrible at it. So if you find yourself in that situation, that's not a problem. That's how it goes. Yeah.
Research indicates that it actually does take 6 times of experiencing or reading something before your brain transfers the memories from the short-term memory to the long-term memory.
On average, 6 times?
Yeah.
Okay.
And so it wouldn't just be philosophy, it would be potentially anything.
Yeah, yeah. I certainly have found that when I'm trying to get a class to really absorb a point, if I don't say it 3 times, it doesn't really. The first time I say it, maybe half the class will get it. And the second half, like half of that, and the third time, almost all kind of thing. So yeah. Okay, so questions about short essay stuff? I know it's pretty far in the future, but so I'll go over this again next week. We'll talk a little bit about structure and formatting and stuff like that. But this should be enough to get you. So if this week you read those questions, thought about which one you're maybe interested in, if you even got to reading the thing once or again, then you'd be making good progress. Next week, you sort of think about what you're going to write. Week after that is reading week. Maybe you write it. You know, that would be a reasonable workflow to kind of really get ahead on this thing. And if you're not in philosophy, I try to do this warning to any class that I'm teaching that's philosophically based but is not full of philosophers. It's a different kind of work than maybe you're used to, especially if you're in the sciences. If you're in the sciences, if you're not reading or using a pen or pencil, you're kind of not working, right? Like the work is you're doing problem sets, you're practicing skills, you're doing memorization stuff. So if you're not like there at your desk, you are not working. And philosophy is kind of not like that. So almost all of the work is just the thinking and the digesting of what you've read or thought about. So like when I'm really working hard on something, I'm taking a walk or like in the shower or like it's very ruminative. It's very like digestive. When you're really ready to write your paper, you should kind of be able to picture all of the main points you're going to make in your head. You should be able to hold the whole thing in your head in some sense, like all the big major points. And that's just a matter of kind of going over it and over it, thinking about how the parts fit together, thinking about the arguments they're going to make. It's a very different style of work, but I assure you that, and it's a kind of work that's really hard to do at 4 a.m. in a sweaty panic, which is maybe different. Like there's lots of work that you can do at 4 a.m. in a sweaty panic. If you just need to get the answers to some math problems, you can just drink unreasonable amounts of coffee and just nose to the grindstone and don't stand up until you got it done. And you really can do that style of work that way. It's not good for retention, but it can be done. Whereas if I promise you I can really tell when a paper has been written in that way. The parts don't fit together properly. People are just saying stuff kind of in no particular order as thoughts occur to them in this manic stream of consciousness sort of thing. I know it very well. And that's not what I'm looking for. I'm looking for something that and so the strategy here is think about it a little bit for a long time. 20 minutes a day is loads. And if you do that for 2 weeks, you'll have done a ton of work. And that what we found out about, for example, sleep, is that one of the main functions of sleep is to help you forget stuff that doesn't matter. So there's a whole bunch of stuff in these articles, a whole bunch of ideas that you might be putting together. You're going to think about a bunch of them, and a bunch of them aren't going to matter. And so having time between thinking about it and then working on it again, having sleep in between there, is you're just sort of using your brain's natural ability to sort important from unimportant drop out the irrelevant stuff, and you just sort of the important stuff becomes clearer and clearer. Every day that you sort of boot it up, work on it a little bit, put it aside, sleep. That's you're using your sort of bodies. It's like a cognitive digestive process, and I'm dead serious. I can tell the difference between somebody who's actually digested the ideas and somebody who's skimmed over it once and written something. Maybe you're just a genius and you can just do this in a one shot. I know there exist people like that, but the chances that it's you are low. Low probability. So, okay, so there's some general methodological advice for dealing with philosophy. Yeah. Okay. So, with that said, any questions about this stuff? Okay, like I say, we'll narrow in. Consider your homework for this week to just read those questions. Think mildly about which ones you might be interested in, and if you're feeling ambitious, going over those papers again going over your selected paper with those questions in mind. And that would be plenty for this week. Let's talk more next week about kind of what I'm expecting in terms of how much time to spend on what and formatting and all that stuff. Okay? Okay. All right, so we've finished off Grinnell. We're kind of shifting now. So Grinnell he's my favorite intro philosophy of science text. I hope that he came off as deeply sympathetic to science, grounded in the details because he's an actual scientist, but also interested in getting you sensitized to some of the complexities and stuff like that. So if that happened, then that's excellent. We've gotten what we're looking for out of Grinnell. We're going to shift now to more philosophical treatments in the sense of philosophy of science written by philosophers rather than scientists. So there's going to be a shift in the kind of tone that we're dealing with. We're still hopefully going to be embedded with scientific practice or engaged with scientific practice, but we're shifting now. If you remember from the very first class, we talked about these two really big questions that you might ask about science. One, which is how does it work as a descriptive question, and one is how should it work? How are scientific claims in some sense justified? Why should we believe them? So with Grinnell, we were more or less doing like, how does science as a matter of fact work? That's of course got a normative sort of slant to it because you can't, if we're saying science is a good way of getting knowledge, then the way that it actually works matters. But now we're shifting into the more normative question of like, how is this knowledge justified? And today we're going to start in with what's called the demarcation question. We're going to assume that science is the good stuff, scientific knowledge is what you want, and try to distinguish science from pseudoscience, so from things that are posing as scientific knowledge but aren't really. So we're trying to draw a boundary around science. I find this practice to be hopeless. I find it very unlikely we'll be able to draw a crisp boundary around science, but it's nonetheless worth thinking about what is characteristic about scientific knowledge. Again, I do think that it's a special kind of knowledge. It's a kind of knowledge that's more likely to be sensitive to the way the world is than other types of knowledge. It's more likely to be sort of generalizable. It's got a bunch of kind of unique virtues, and it's worth thinking about what makes science what it is. So I don't know. So what makes something science? Making observation. Yeah.
The hypothesis, the reproduction of studies, the falsifiable claim like a
Okay.
claim that can be falsifiable.
So if it's true that it has to be reproducible, then observations of, for example, one-off events aren't science. Like if you see an astronomical event through one telescope, it's not science.
Simulations. So more.
Well, that's not reproducing the experiment or observation. No, it's not.
I think it is. if the simulation is good enough, then you've effectively reproduced the event.
You haven't.
Yeah.
No, you haven't.
Okay, so if you've ever worked with a game engine, you can like there's a physics engine within the game engine, and you can actually like create whatever details you need to create of the real world within the environment.
But this is assuming that you know what the details of the real world are. When we're doing science, we're doing it about things that we don't already understand. So if you get, for example, people who do astronomy get this all the time. You see a thing in the sky, and you're like, what was that?
Okay.
I posit that that's a scientific observation. I assume they wear lab coats. I've never been to a radio. I assume they wear lab coats and maybe have stethoscopes just for super sciencey and pocket protectors and stuff. So they're real scientists. They're using scientific instruments. They've got PhDs. They make an observation, but there's no way to repeat the observation. Is that not science? No. Okay, yeah, another thought back here, yeah.
I would say that science is following the specific paradigm of a specific science.
Okay. It's a bit of a circular definition though, because you've used the word used the word science. So when we're trying to come up with, so the game here is trying to come up with a demarcation criterion. We're trying to be able to separate those activities that count as science from those that don't.
I would say something becoming scientific is the fact that it is reproducible. So
No, we just did that one.
The definition can be circular if what you're trying to do is get something that like is a fact, is provable, like it just is.
Okay, we'll come back to this. We've got a few other. Sorry, I saw your hand in the back first, and then we'll. Yeah.
Whatever the society believes. As anthropologists, in all
It's
honesty, they thought like witchcraft was a science. They thought philosophy was or not philosophy.
No, well.
Philosophy is a science, but
Nah, is it?
What is it? Alchemy.
Alchemy.
They thought was a science as well, and like there's just like depends on what culture you look at, what time period you look at. Everyone considers whatever they're doing a science kind of to a degree.
Okay, that's a very descriptive. So there are facts of the matter about what people call a science, and now So now once again, the game that we're trying to play here is to try to push back a bit. So what we want is some rule to say, no, you're wrong. You think you're doing science, but you're wrong, and you think you're doing science, but you're right because you're wearing a lab coat and you have a pocket protector, or something. I don't know. That might be that, and making graphs might be the whole story. No, okay, so. That's a kind of, in some sense, it's a very safe answer because you're like, look, there are just facts about how people use the word science, and those are the facts. So, yeah. But if that's in some sense to give up on the game, and that might be the right move here. The right move might be to just say, look, there's no, people use words however they want to use words. There's no fact about how we should use the word, but. Come on, we're trying to do philosophy. We're trying to do philosophy here, where we give normative answers, push people around linguistically, and say, stop using that word that way. That's the game, sort of. Yeah. Objectivity. Yeah. Which is hard. I mean, it's hard one to. We've been talking about this. That's a hard one to nail down in terms of exactly what you mean by objectivity. So that doesn't distinguish. Some people want to distinguish things from science from like math or logic or something like that. So I take it observation is usually taken to be one of the necessary features of a science. You got to have something that you're looking at in the world. Some people resist that actually. They want to go ahead and say no, math is part of science, logic's part of science. That's all fine. But so here's a. Again, there is a good descriptive question about how people actually use this word. But so, and okay, and you. Yeah.
I was just going to say that I assume it's something like novel predictions that refer to the way that the universe observationally appears to be.
Okay. You gotta give me more than just making the predictions though, because I can predict all kinds of things by looking at a crystal ball.
So the methods.
Something about the methods. Yeah. So here was my quick. Yeah. Oh, sorry. Go ahead.
The only difference between fooling around and science is writing it down.
Okay, good. Okay, let's test that out. So maybe here's three things using observation. Let's add that in. It's got to involve observation. So just as a conventional matter, we'll set aside math and logic as not science because they don't do. Not that they're bad. It's not that they don't produce good knowledge. It's just they're not doing the observational part of it. You might want to require that we describe those observations with mathematical language, right? We're not just writing them down. We're writing them down in a quantitative way. We're doing numbers about this stuff. That's iffy. There's some social sciences that are purely qualitative, but let's take it. And then maybe even want to go further and say, no, we're just not going to just write these observations down. We're going to combine them somehow into overarching theories about the world. So maybe you do want to include all of these, but these are ancient Babylonian astrologers for whom all of this would have been true. So they made careful observations of where the stars are in the sky. They described those observations mathematically. They developed a lot of the math that we need in order to make those claims. And they combined those observations into theories. But the theories were things like the gods are pleased with the king because the lunar eclipse showed up when we thought it would. Is that science? Yeah.
I wouldn't say that's science because that's not referring to the way that the world actually is.
Well, do you have to be right to be scientific?
Yeah, and I think that.
Oh, geez, okay.
I think that you have to not be right in your observations at first, but
Yeah.
lend to falsified theories that can actually progress into something that.
Okay, falsifiability again. Yeah. Sorry. Yeah.
It can't be led by ideology.
Right. So it can't be led by rigid, unexamined assumptions. So they've got in this structure, they've got a sort of theological overlay, and it's actually a very common one in ancient cultures. So there's this in ancient Babylonia, ancient China, a whole bunch of the major civilizations. The regularity of the heavens was taken to be an indicator of how good the gods think the leader's doing. So when unexpected weird stuff happens, like if there's an eclipse that you didn't predict, that's evidence that the leader's doing badly. So there's a lot of pressure to learn how to make good observations and predictions, because the more you can predict, the more you kind of build into, oh no, the gods think I'm doing fine. We called this one. Yeah.
I can ask good questions if that's quite all right.
Sure.
Anthropological kind of.
Yeah, let's do some science. Yeah.
All right, so there was a case study, or there was a thing where they were examining skulls of black people and white people, and were saying that they were less intelligent because their cranial capacity is smaller than white people, and they were doing all these measurements, all of this, and they all were able to prove it. This was mid-1800s. Would that be science to you guys?
Oh boy.
I didn't want to talk about phrenology.
Well, this is not phrenology. So is this coming from Gould's The Mismeasure of Man?
I'm not.
Okay, if you haven't read that one, Stephen Jay Gould wrote a really good book about this called The Mismeasure of Man. Basically about this. So they took a bunch of skulls and filled them with BBs to measure their total internal volume and use total internal volume as a proxy for intelligence. Basically trying to do race science, trying to show that there's biological differences between different races. So is that science?
Is that maybe led by an ideology though?
Right. So what's sort of delivered onto this research program is the belief in clear biologically distinct races. And the more people actually do science about that, the more we find that there's not really any dividing lines. No. Yeah. Nobody wants to touch that question. I guess yeah.
I'd say that there's probably an ethical portion to science. That what is science also depends on what the ethics were at the time.
Right. So you need a basically decent ethical framework in order to be doing science or something like that.
Or at least to not make harmful science.
Well, that's certainly true. That's unquestionably true. Yeah,
But truth has nothing to do with ethics.
disagree.
Well, okay, so let's say I discover something horrible about the world that if I tell other people, it would cause society to collapse.
Uh-huh.
As a good scientist, I still have a responsibility to tell people.
Do you? Okay, that's okay. Okay, yeah. Okay. If you think of it again. Okay. Okay, so we've kicked around a few ideas. I'm not trying to lead you anywhere. I don't know the answer to this question. I don't have a short and snappy, here's what science really is. So none of this was leading questions. What we're going to do today is kind of go through some of the proposed answers, and particularly one from Karl Popper, which kind of came up a few times, which is falsifiability. Yeah.
I just wanted to mention one thing. I think definitely, personally, with science, not going to stop. There's definitely, the thing is, I think, I know science is kind of subjective.
What counts as science?
What counts as science is very subjective.
Oh.
What counts as science in the 1800s is subjective to them. We don't think that's good science anymore, but it was science at that time. What the Babylonians think was science to them was
Yep.
science to them, but we don't think it's science. So
Yep.
it's just very subjective.
I can hear my historian friends talking in my ear right now, telling me to point out that the word science, for almost all of history, nobody would have described themselves as a scientist. The word science doesn't come around until mid-1800s or something like that. So if you want to say that Newton was a scientist, Newton would have no idea what you're talking about. He'd say, no, I'm a natural philosopher. So these guys would definitely have no idea what you're talking about when you say science. The idea that science and philosophy are separate disciplines is relatively recent. So like Galileo, again, had no idea. You say, oh, you're the great scientist Galileo. And I mean, I guess you'd have to say it in Italian, but even if you did, he'd have no idea what you're talking about. No. Yeah.
About the ethics.
The ethics thing, yeah.
So when the Nazis were experimenting on Dutch prisoners,
Yeah.
and they made quite a few scientific achievements.
I mean, they discovered some scientific facts. Yeah, yeah. So here's the question that we might not have a principled answer to. Okay, so science, very first thing, I'm like, science, that's the good stuff. You may or may not want to say that it's the ethically good stuff. I think it's, so unless you think there's a contradiction in the following sentence, the science was used for evil. I mean, that if you think that sentence is a coherent sentence, then you don't want to say that science is always working towards ethically good outcomes. You might want to say that you do need a certain degree of ethics in order to do science properly. So we talked about ethical misconduct in science. If every scientist is just a flagrant liar, I think the whole thing kind of comes apart. So you need people to be minimally honest, cooperative, that kind of thing. But you might not want to say it only counts as science if it's working towards some moral good. So that's the kind of, this is why I want to push back against science has always got to be, or science is nothing to do with morality. I do think you need baseline morality and social order. And like, so we saw that example of Lysenkoism where if you're living in a full-on totalitarian society, you just can't do science because disagreement is political dissent is a crime and therefore you go to the gulag. You can't have science under those conditions. So you need a minimally open society, you need people who are reasonably honest, you need cooperation, but not total social control in order to have science. So you need ethics to do science, but it's not clear to me that, and I don't mean this rhetorically, I don't mean like, I think it's not, and fight me if you do. I think I just really don't know whether we should build in the purpose or the goal to which it's moving is an ethical question. Should we build that into the word science or not? And here we get back into the kind of descriptive question about how do people use science. I think you can be a mad scientist, right? You can be an evil scientist. That's a fairly common trope. So maybe we don't want to build in that it's got to be for ethical purposes to be science. So then we could say this science is evil and we should stop it. And it's not a contradiction in terms. You say, no, but science is the good stuff. Yeah. Sorry, I thought you got your.
Oh, that was a while ago.
Oh, it's past. Yeah. Okay, okay. Sorry, this is happening a lot today. Okay, okay, so good. All right, so we're gonna warm our way up and try to get to Popper today. We'll talk a little bit about Popper. So, before Popper tried to do his demarcation criterion to distinguish science from pseudoscience, there was a big group of philosophers who were really interested in trying to distinguish science from metaphysics. Like following Immanuel Kant, who big famous philosopher, Kant's huge philosophical project was to try to get people to stop doing metaphysics that they had no right to do. Like he thought that a lot of people were doing what he called dogmatic metaphysics, metaphysics that were just sort of like, I think the world is made of ideas, or I think the world is made of monads, or I think the world is made of this or that. And he really thought they had just no basis for doing that stuff. So Kant tried to sort of carve off the questions that could be reasonably answered from questions about which you're going to come up with nonsense. How many angels can dance on the head of a pin style question. And he's just trying to get people to stop doing that. The logical positivists, kind of early 20th century movement, were in the same kind of business. They spent a whole bunch of time and energy trying to separate out questions about which you could produce meaningful answers and questions about which you're just going to come up with nonsense. And they had a specific tool for trying to make this distinction, which they called the verification principle. So the verification principle goes like this. This is a kind of rule of inference. It's a rule to try to distinguish which sentences are meaningful and which sentences are literally meaningless in the sense of just not being unimportant, but being linguistically malformed. So if I say sugar is water soluble, what does that sentence mean? We get the meaning of that sentence by describing the kinds of observations that would show you whether it's true or false. So of course you dump some sugar in some room temperature water, it dissolves. That shows that it's true that sugar is water soluble. So what they're trying to do is tie the meaning of any sentence to the kinds of observations that would show you whether it's true or false. And if you can't come up with some set of observations that would show you that it's true or false, they say, that's not a meaningful sentence. It's gobbledygook. Metaphysics, which they use as a kind of term of abuse. They think metaphysics is bad, don't do metaphysics, you're just talking nonsense. So what they had in mind were, this guy comes after them, but here's a quote from Heidegger. To think being itself explicitly requires disregarding being to the extent that it is only grounded and interpreted in terms of beings and for beings as their ground, as in all metaphysics. Okay, so I do not know what observations would confirm or disconfirm the claims that Heidegger is making here.
No, where? It doesn't flow.
Okay, so this is the style of thing that the logical positivists, Heidegger wrote this after the heyday of the positivists, but this is the style of sentence that the logical positivists would have said, that's not even wrong. That's meaningless. It doesn't have any cognitive significance, you might say, because I can't translate that into some set of observation sentences that would correspond to its truth, or observation sentences that would correspond to its falsity. Yeah?
This might be slightly off topic, but is this why people hate Jordan Peterson?
No, it's because he's a jerk. What is that? I mean, you think that he's making meaningless claims?
I mean, I've heard people say that before.
Okay.
It's slightly off topic.
We're gonna this is a precipice over which I've fallen a few times, where we spin wildly off into just talking about JP for hours. So maybe we don't want to do that.
He's trying to fill the role of a father figure. End of story.
That's What's wrong with that? I mean, everybody needs a father figure. Okay, we're not gonna, sorry. It's a fascinating question which would take us way too far afield to, I was a fan of his for years actually until he started going on about gender.
Going into politics and like social stuff.
Yeah.
Going into philosophy.
Yeah.
To describe other people's lives. And
I was way into Carl Jung for many years, and I thought that he was just sort of delivering Jung in some sense. Short anecdote. I once twice actually, I moderated a panel discussion that he was on. One of them was about religion, and I asked the panel, if you could design a religion, what features would you give it? And they all kind of looked at each other, and Peterson pipes up, I would make it funnel a lot of money to me. Yeah. Anyway, food for thought. Okay. Okay. So back to the thing. All right. So, oh boy, this is a weird place to jump into this lecture with this Heidegger quote. Okay. Okay. So the verification principle, the meaning of a sentence is given by its method of verification. So what we're trying to do is make the good stuff, the meaningful stuff, the interesting stuff that you can tie back to observation sentences, stuff that you can connect to how you would tell whether it's true, right? What observations would confirm the truth of your sentence? And if you can say that, you can definitely say what the meaning of the sentence is. Stuff like math and logic, they think is just sort of showing how the language itself works. So in some sense, those are empty claims, but they're not useless. Couple of problems for this. So this was a proposal, and it kind of fell apart. Mid 20th century, people start worrying about this. So here's a broad sort of worry about this. Can you here's a scientific. I propose this as a scientific fact. Copper is conductive. Can you verify that? Yeah.
You can verify copper is conductive with all copper.
So the generic copper, there exists conductive copper, yeah, or generally copper is conductive. But is this the kind of thing you can verify? How much copper do you have to test? Yeah.
I don't know, I was just going to say, if we're going to actually go into logics and deal with this with logics, then no, you can't verify that.
Yeah. Yeah.
Because that would be like a hasty generalization unless you literally found every piece of copper and tried to do something with it.
In the universe. You'd have to go to all the copper in the universe and test it.
What's the example of like swan? Is it swans or some kind of bird that's usually one color and that's a different color?
Yeah. So philosophers' favorite example of a universal claim is all swans are white. And they use this as a very common example, so the kind of thing that you might try to confirm by observing a bunch of examples. It turns out that there's a bunch of black swans in the world. In Australia and New Zealand, they're more common to be black than white. It's just the philosophers who use this example mostly hung out in Europe. So like they didn't get around much. So they didn't know that their favorite example of the kind of thing that you'd verify with induction or looking at examples totally is not true. It's not at all universally true. Loads of black swans in the world. Yeah.
Can you build like a self-referential definition? So you just say, if you find copper that isn't conductive, then it's not copper.
You could do that, but that makes it vacuous. That makes this claim vacuous.
Okay.
Because, you say, if it's not conductive, then it's not copper. But we're supposed to be learning something substantial about copper, right?
Okay.
It's supposed to be not just by definition that it's conductive. It's supposed to be an empirical observation in the world. If you make it part of the definition of copper that it's conductive, you don't get that empirical content that was precisely supposed to be what grounds the meaning of this stuff. If I say all copper is valuable, that's, and I'm saying it's by definition valuable, then as soon as the price of copper drops, like all the copper disappears from the world. Like, that's not how you want your words to behave, right?
Okay.
Okay, so yeah.
So what would their claim about copper look like then?
Well,
Or would it just be like in this study or something?
yeah. So there's things that you can do that the logical positivists weren't willing to do to make this claim something that you could verify. So for example, you can say things like, there's a natural kind. There's a kind of stuff in the world that's copper, and that kind has the property of being conductive. Now that's talking about natural kinds is getting a bit metaphysics-y. It's a type of thing, and a type sort of stands above all the examples of the thing. It's separate from it. And that's exactly the sort of nonsense and malarkey they were trying to get away from. So if there's some philosophical moves, you can add in some metaphysics or some extra beliefs that are hard to verify with observation, but you can add in some extra beliefs that makes it such that you can do, I mean, I think take it that the amazing, beautiful thing about science is that you can do tests on one sample of copper and learn about all the copper in the universe. That's a neat trick. That's a really neat trick, and it's not something you can always do, but in order to justify that, you better not be basing that on the percentage of copper in the universe that you've tested. That projectability is a really sort of interesting property of some categories of things like copper. And the positivists had a lot of trouble cashing that out. Yeah. Okay, so there's one issue. So maybe we don't want to talk about verifiability in practice. You might want to talk about verifiability in principle. So Tyrannosaurus had a mighty roar. There's a sentence which I take it is meaningful. I hope that didn't strike you as literal, like gobbledygook nonsense, right? But since they're all dead now, it's not clear how in practice we would go verify that. So maybe we want to talk about, but in principle we know. So hanging around a living Tyrannosaurus and seeing how it roars, that would be a good way of verifying that. So at least we know in principle what kind of observations we would look at. So at least we might say, if we're willing to make this in practice and principle distinction, we might say something like, look, I know I can't run around the whole universe testing all the copper, but it's nonetheless a meaningful sentence, all copper is conductive, because I know what kinds of observations I'd have to perform in order to say whether it's true or false. So it can be hard to say that this is clearly true, but at least we know that it's meaningful. Yeah? You can't confirm it completely, but at least it's a sentence that's not, it's not this thing. Yeah? So that might help. That's something. Here's the deadly Ouroboros dragon that, speaking of JP, that seems to have brought down this as a principle. So they say, look, the logical positives say, look, there's two kinds of things that you can say and not have me yell at you for talking nonsense. One thing is logic, things that are true by definition. One thing is things that I can confirm with observation. And some smartass comes along and says, great guys, so which of those two is your verification principle? Doesn't seem to be true by definition, but it's hard to say what observations would confirm or disconfirm it. Oof. So it kind of looks like the verification principle fails its own test for meaningfulness. I am gliding lazily over this huge debate. So people obviously kick back on this. They tried to say that, no, we can make it meaningful this way or the other. But for our purposes, this is kind of, nobody really sorted this out to anybody's satisfaction. It's hard to make it a logical principle, and it's not obvious what observations would confirm or disconfirm it. Yeah, so, oops, concerning. And these are, the logical positivists are kind of they're not the kind of people who would be like, don't worry about it. They worry about like if it's not very rigorously defined and clear, they're not having any of it. So for them, this was kind of a catastrophe. Yeah, anyway. Okay, so, oof. Yikes for verification. Briefly, let's do this and then we'll do a break and then start talking about Popper. So Popper's problem with verification is actually that it seems too easy to satisfy. So here is my astrological chart. And as you can clearly see, I've got my Mars in Gemini, which, as everybody knows, means that you're kind of scattered and easily bored. And as you can also clearly see, and everybody would realize, simply looking at this quickly, I have Jupiter conjunct Saturn up here, which, as everybody will know, means that I'm sort of hardworking, patient, and serious. So if you see me being flaky and scattered, you can explain that by my Mars in Gemini. And if you see me being hardworking, diligent, and serious, you can explain that with my Saturn conjunct Jupiter. So his worry about this is not that you can't come up with observations that would confirm the theory. His worry is that the theory generates too many observations, potential confirming instances. So whatever happens, astrology is going to have, there's going to be some way that you can look at my astrological chart and fit it into that theory. Yeah? It produces too many predictions. There doesn't seem to be anything that it would fail to explain. Yeah? So that's why Popper thinks that, every observation actually verifies the theory of astrology, right? I'm flaky, clearly that's explained by this. The theory predicts that you're going to be flaky. I'm not flaky, that's predicted by this. Clearly the theory predicts you're not going to be flaky. So it seems like this theory is in some sense too good at generating observation claims that would verify it. Yeah? That's his concern with things like astrology. He says, this theory, it's not that it's hard to verify, it's too easy to verify. There's too many observations that would fit with it. Let's talk about Karl Popper. So Karl Popper, he's kind of working early to mid 20th century, and he's concerned about trying to figure out, he thinks science is just the best. And what he wants to do is not distinguish science from metaphysics, but distinguish science from things that have kind of wrapped themselves in the legitimacy of science, but aren't real science. He wants to determine what makes something real science in the sense of generating good, justifiable beliefs. And he's specifically worried about things like Marxism and psychoanalysis. So he's hanging out in Vienna in the 20s and 30s. There's a bunch of Marxists and psychoanalysts running around. And what he finds is, when he's having conversations with these people, there's just nothing you can say to them that they can't work into their framework. Like, there's nothing that you can say to a Marxist at this point that they won't be able to interpret through their Marxist framework. So you say, rents are going up. You say, the bourgeois are squeezing the proletariat. You say, rents are going down. Like, clearly that's deflationary and that's evidence of capitalism unraveling itself, right? Like, there doesn't seem to be any prediction or any fact of the matter that they can't in some way interpret through their picture. And this is worrying to Popper. Yeah.
We are always in late stage capitalism.
Well, not when we were early.
But they've been predicting that capitalism is about to end for the last 100 years or so.
Yep. That's true. That's true. Sorry. Make sure my mic is plugged in. Okay. And basically the same thing about psychoanalysis. So if you say, I had a dream where my father was mad at me, the psychoanalyst says, yes, that's exactly in line with my picture of psychoanalysis. So I had a dream where my father was happy with me. I say, yes, exactly in line with our theories. There doesn't seem to be any kind of psychic configuration that the people who were doing psychoanalysis at the time couldn't somehow wrap into their way of thinking about the mind. And he's like, no, that's what makes something not real science. So he's quite aware of the verificationist program, and it's not going great at this point. So he tries to come up with his own criterion. So instead of verification, he says what makes something scientific is whether it's falsifiable. That is, whether it makes predictions that could turn out to be wrong. So risky predictions is the thing that makes something a scientific theory rather than a pseudoscientific theory. Now again, he's not trying to, so he's got a slightly different project than the positivists had. The positivists were trying to talk about meaningfulness. He's trying to say whether something is real science or fake science. So he's not going to say that the things that psychoanalysts say are literally meaningless. It's not that they're meaningless, and it's not even that they're valueless. So just because something science is not science, Popper says, doesn't mean that it's got zero value. It could have some worth to somebody. Actually, I think astrology is very valuable. It's a fascinating, if you get a good astrologer or like a good tarot reader, it's a very interesting process. It helps you reflect on things. It helps you think about your life in new ways. I don't think it's science. I don't think it should be evaluated according to the standards of science, but it is a very interesting and kind of like potentially worthwhile thing to do. So Popper's not saying that non-science is nonsense. He's not saying that non-science is valueless, but he does want to carve out this kind of special class of claims that have a special status, and what he thinks the criterion should be is whether they make risky predictions. So here's his classic example of this. So the 1919 Eddington Eclipse experiment. Have we heard of this before? Oh, okay, great. Okay, most of you not. So 1919, Einstein's theory of relativity was not yet accepted. Like generally, like he's published it, people are talking about it, but there's not yet any experimental evidence or observational evidence that would show that it's right. So it's sort of an open question whether this is a good theory or not. But in 1919, there was a solar eclipse, and this provided a really nice opportunity to test the theory, because all of the other theories of physics at the time predicted that light always goes straight, whereas Einstein's predicts that gravity bends light. So Einstein's theory of relativity is the only theory on the books, the only theory that people are talking about that has this feature of if light moves or travels close to a big massive object like the sun, it'll be bent slightly. So during an eclipse, you're able to point your telescope really, really close to the sun and still see the stars. So Eddington and a few other people set up a telescope, pointed it really, really close to the sun during the eclipse, and what they wanted to see is, are the stars displaced? Are you seeing stars where they shouldn't be? So you know where the stars are supposed to be. If I point my telescope here, I expect to see these stars. And if it's really close to the sun and you see stars that are a little off to the right, that means that the light has been bent. Therefore, Einstein's theory is probably a good one. So they did this experiment. Turns out the light was being curved. Einstein's victorious, hooray. Okay, so it's a very risky prediction, right? Like Einstein's the only, and he not only says that he thinks that the light will be bent, he says how much it should be bent by. So he's able to tell you which stars he thinks you'll see when you point it really close to the sun. Very risky prediction. Very weird if you just guessed and got it right. And very likely, according to everybody else's picture of how the world works, to be wrong. So if anybody else in physics was right, Einstein would turn out to be wrong. So it's a very risky prediction. It's a prediction that if his theory isn't a good one, hard to say why it should be correct. So, right. So, if we're going to strip this argument, I'd like to take a minute and kind of look at the form of this argument. Strip away the details of the argument and try to look at how it's structured, because I think it's got a really interesting structure. So, if theory T, in this case the theory of relativity, is true, then we should make observation O, that the stars aren't where they're supposed to be. We did observe O, therefore the theory T is probably true. That sound about like what I just described? Okay. So here's that in an even more schematic form. If t then O, O, therefore t. Has anybody here done logic? Yeah? What is that? What is that called? No. No, that's a valid argument form. This is called affirming the consequent. That's a fallacy. So let me show you another thing that fits this argument form. If somebody stole all my money, then I would be broke. I am broke. Therefore, somebody stole all of my money. Now, a valid argument, if the premises are true, then the conclusion's guaranteed to be true. But of course, those two premises could be true. It's true that if somebody stole all your money, you'd be broke. That's true about everybody. I am broke. Suppose that's true. Does this follow necessarily? No. Lots of other, maybe you spent all your money. Maybe you're a student and didn't make that much money. Maybe late-stage capitalism is crushing the proletariat, and that's what's going on.
The Marxists would say that the capitalists stole
That's
all the
right.
money.
That's right. That's right.
Obviously, that's what happened.
Right. Okay. So that's a bad argument. It's got the form of this argument, which has got the form of this argument, which has got the form of this argument. But when I said this thing, it was like, yeah, that sounds right to me. Oh yeah, that sounds good. Right? Something weird is going on here. Right? So I think this is a really strong case for Einstein's theory. Like if Einstein's theory makes a prediction nobody else is making, you got no other theories that could account for it. And the prediction turns out it's a really risky prediction. It's weird, it's off the wall. Light bends when it goes near massive objects. And it turns out he's exactly right. Not just overall right, but like down to the numbers right. Seems like that's a really strong argument for the theory. And then as a matter of historical fact, people took this to be really strong evidence for the theory. So, yeah. Now, if you make this, this is what's called a conditional. If you make this a biconditional, say if and only if t then O, then you got something going on. Then it's a logically fine one. So you flip it around. So if you make observation O, then t has got to be true. This explanatory structure is what's called inference to the best explanation. So it's not a logically valid deductive argument, which is to say the truth of the premises does not guarantee the truth of the conclusion. Now, nobody thinks that it does guarantee it. So what we need, so it's called inference to the best explanation. The best explanation of why we're making this observation is Einsteinian relativity is true. Now, that's not a guarantee, and it assumes that there's no other way to explain it. So what makes this a terrible argument is that there are obviously other explanations for the second premise here, right? So it's not inference to the best explanation. This is inference to the most self-serving explanation or something like that, right? So there's clearly other explanations we could generate here. What makes the Einsteinian thing better is that nobody else had a theory. Now, inference to the best explanation only works to the degree that you know all of the possible explanations. It's not clear that we have access to the set of all possible explanations for something like light bending. So it's a kind of provisional inference. It's an inference that doesn't give you the conclusion with certainty. It's an inference with a bunch of assumptions in it. And this might all worry you. And it worries Popper. Yeah. In some sense, yeah. Line of best fit's an interesting analogy because you're like, well, given these data points, this looks like a good line that would explain those data points. Yeah, yeah. So Popper's a an obsessively rigorous thinker, as a lot of these people are. And if he thought that we use evidence to prove that our theories are true, this might have really worried him. But in fact, Popper's going to make this very strange claim. He kind of flips things on their head in terms of the normal way we think of this stuff. So the normal way of thinking about science is, first you make a bunch of observations, and those observations in some sense add up to showing that the theory is true. Popper kind of doesn't think that's right. And he doesn't think that that's right mostly because of this old philosophical problem, the problem of induction. Okay, so I can only do this really briefly. I despair of convincing people that this is a real problem if they're not already in philosophy. So if you don't think this is a real problem, you're in good company. Many people don't. But there's a kind of so induction is using a specific observation or set of observations to justify a general rule. So I've tested the conductivity of 100 samples of copper, and now I say copper is conductive, or all copper is conductive. Or, for example, the sun has risen every morning for as long as humans have been alive, therefore tomorrow the sun is probably going to rise. That's induction. So you're saying, here's a bunch of specific things, and I'm going to go from those specific things, I'm going to use them to justify a general rule, a universal rule even. Now, David Hume points out that there seems to be a little leap in this logic. There's a kind of missing premise in that argument. You can't just say, I've seen 100 white swans, therefore all swans are white. Right? That one actually turns out to be false. The missing assumption, so here, all observed emeralds have been green, therefore all future emeralds we observe will be green. The missing assumption is the past resembles the future. The future will resemble the past. Yeah? The uniformity of nature. That nature has kind of regularities in it. That nature behaves itself. There's nothing logically wrong with the idea that every day since humanity's begun, the sun has risen in the morning, but tomorrow it won't. That's not a logical problem. Yeah? There's no logical contradiction in that. And you can tell that because sometimes things do change, right? I mean, for the entire history of humanity, nobody was able to keep their feet off the ground for more than a couple of seconds until about 1904, when we did. So you can't just go from, it's always been this way, so it always will be this way, right? Things sometimes genuinely change. What we need is this assumption of what we may call the regularity of nature. Nature is regular. The future will resemble the past. Okay, so I assume that we all kind of think that. I think that. But why? And don't say induction. Because that's the thing we're trying to ask, what does induction work? How do you know induction works? How do you know you can make a bunch of observations and use them to generalize? Because it's always worked in the past. Aha. Yeah, but you just used induction to try to show that induction is a good rule. The problem of induction. Yeah.
Doesn't it end up being about like physics? What
about physics?
Well, so like you have the laws of physics that govern how things behave in reality.
Uh-huh.
And they just are always that way.
Why do you believe that?
Because we have recordings going back.
Aha. So you're using induction to justify the belief that the laws of physics are regular, which is what you're using to justify induction.
But in this case,
Do you see that that's circular reasoning?
it is. But in this case, the recordings go all the way back to like the beginning of time.
Doesn't matter.
Shouldn't it?
No.
Okay.
Because the inference from, I mean, I agree, it's a vast amount of evidence, But the connection between that evidence and our predictions is an inductive inference. And if the very question is how do you justify inductive inferences, you're not allowed to use inductive inference.
But what if you take into account the fact that there's no reason to think that something should change? So if there's nothing that would cause the laws of physics to change and then make past events irrelevant.
You're assuming that there has to be something causing it to bring about change, but maybe they just change sometimes. There's nothing logically incoherent about the laws of physics just changing. Sorry, I saw two hands. Yeah.
Is it possible that you could use induction to find something that's deductive?
Yeah, good. That's an interesting thought. So maybe what we discover when we do enough physics is some laws of physics that are in some sense true by definition. We turn out that the laws of physics are just the laws of logic. And then you're not using induction to justify deduction. You just to justify induction. What you're saying is just you used induction to discover a deductive rule. So you can discover mathematical laws this way, right? So you can use a bunch of observations to discover. So if you are trying to work out the Pythagorean theorem, maybe you just measure a bunch of triangles and you say, I see a regularity in here. And then what you end up with is the theorem, but the theorem can be justified deductively. So you're not saying it's the observations that justify your belief in the theorem. You're saying, I use these observations to figure out the theorem, and then I can prove it using deductive methods. So far, we're not narrowing in on deductively valid laws of nature, but who knows? So that's one way out of that. Yeah. Other thoughts on the nasty problem of induction? So Hume thinks this is just kind of a habit that we have. It's a thing we do. It's a psychological fact about us that we do inductions, but that is not actually justified, logically speaking. Okay. I'm gonna go ahead and continue to use induction personally. I'm not gonna. This argument in no way convinces me to stop using it. But if we're trying to logically justify our scientific beliefs, Popper thinks at least, this should worry us. Yeah.
Isn't it because it doesn't provide certainty?
It's
Yeah, because if you're dependent on the past, predicting the future.
It's much worse than that. It's much worse than. So the temptation is to think that this shows us that we can never be certain about induction. This actually shows that we have no reason to believe inductive evidence. It's a complete collapse of justification, because assuming circular reasoning is not okay, all of our inductions are based on our inductive evidence that induction works is completely undermined. That's the conclusion you're supposed to come to. Yeah.
Point.
Yeah.
One, maybe to try to answer that, you should almost take a psychological point of view a little bit in the way how our psyche kind of works, in that induction is kind of important for survival and that kind of stuff. So it's kind of, and then also this reminds me most of, is the yellow I see the same yellow as you see kind of thing? Like it was a lovely little rabbit hole. It is absolutely a rabbit hole. So I don't think, okay, so we should be very careful about the question we're asking here. And I don't think psychology helps, because everybody agrees, as far as I can tell, that we do, as a matter of psychological fact, use induction. And I'm pretty comfortable with that. I don't have any worry about doing that. But the question is not whether we do it. The question is whether it's justifiable. So this is the shift that we've kind of made in the whole course. We're shifting from descriptive questions to normative questions. So what's the justification for using induction? Now, I think circular reasoning, probably we should just get comfortable with the idea that we're going to do some circular reasoning. Maybe our beliefs are more of a web than a pyramid. That might help. Yeah.
Well, I was just thinking about what you said. Didn't you mention something before? Somebody said something about we kind of have to accept that we necessarily have to use induction to form theories, but maybe we need a more deductive way of taking them apart. So is that just kind of how we have to go about things, inductively making our theories, and then kind of, I can't figure out exactly what the deductive
I mean, that's exactly where Popper's going to go with this. You got it, you nailed it. Yeah, yeah. So do you want to, like, we can just go on, or for a couple of final thoughts. Actually, this is the least incredulous a class has been about. Usually people are outraged and try to go to the dean and say we shouldn't fund philosophy anymore when I do this. Because like, how dare you say induction doesn't work, you monster. I sympathize, but like, yeah.
Did you say induction is useful?
You could say that, but what you're saying is induction has been useful in the past, and therefore you should expect that induction will be useful in the future.
But I can show that it's useful in the future.
Not without using induction. So what you can say, unless you have access to the future, tell me, because I want to know what cryptocurrencies to invest in. If you know about the future, then you can do that. But any other scenario, you're using knowledge about the past and assuming the regularity of nature to make projections about the future, and that's what induction is. So again, we're using induction to justify induction.
That makes sense, but at the same time, like, you wouldn't even be able to walk out of this room if you didn't.
I know. If a philosopher is being annoying about this, ask them how they justify deduction without using deduction. That'll put a fork up their nose. Yeah. That's not even an expression. Okay.
Couldn't you just say that we operate off the assumption that induction is going to continue to work?
Of course.
If it doesn't, then we've recognized the falsification of whatever thing it is that has been proven wrong.
Yeah, I mean, but all of that was descriptive. All of that was, here's how we actually do it, and everybody agrees that we do it that way. But then the question is it justified? Okay, so this, Popper's real worried. Popper's deeply convinced that this is a serious problem. He's real worried about this. And he thinks that it actually has nothing to do with how science works. So he thinks induction is unrelated to how science works. He says the following. This is from his most famous book, The Logic of Scientific Discovery. He says, a theory of induction is superfluous. It has no function in a logic of science. Now notice his language there, a logic of science. He's not saying the practice of science. He's not asking how scientists actually operate. He's asking how could their theories be justified. So remember we were talking about you could discover the Pythagorean theorem by just measuring a bunch of triangles, right? That's distinguish the method of actually doing the practice of coming up with the idea versus how you justify it. So Popper's exclusively interested in the justification step, not the how did you come up with the idea step. So he says, the best we can say of a hypothesis is that up to now, it's been able to show its worth. And has been more successful than other hypotheses, although, in principle, it can never be justified, verified, or even shown to be probable. This is a radical stance. Okay. This appraisal of the hypothesis relies solely on deductive consequences, predictions, which may be drawn for the hypothesis. There's no need to even mention induction. So, the picture is something like this. You come up with a hypothesis. Doesn't matter where from. Now, if your hypothesis is all copper is conductive, hard to justify with induction. You got to go all through the universe and look at all the copper. But how can you show that that's false? Your claim is all copper is conductive. What would you need to show that that's false? Yeah.
A piece of copper that's not conductive. So going off what I said before, I'm assuming that he means basically kind of what we were saying, except instead of doing the Einstein thing and testing to see if it's true, you test to see if you can find something that proves it wrong.
Exactly. So that's exactly it, yeah.
Okay.
One single disconfirmation can show you that the universal's false. If your claim is all copper is conductive, you find one piece of non-conductive copper, you've shown that that's false. And that's a deductive relationship, right? There's just an incompatibility between all copper is conductive and this copper is not conductive. There's always a relevant XKCD. So Popper thinks that the method of science is you put out hypotheses and he doesn't give a crap where they come from. Make them up. Do a bunch of acid. Read tea leaves. Who cares? Come up with a hypothesis however you can come up with it. That's irrelevant to the process of science, or to the justification of science. Once you got a hypothesis, then you do your level best to show that it's false. You run a bunch of experiments that would test its truth or falsity, and what we end up with in the theory, and in the end, is never a theory that's proven true. It's a theory that's the one that stood up against our attempts to show that it's wrong. Yeah? So really, when you're testing a scientific theory, you shouldn't be looking for evidence that it's right. Think of astrology, right? Easy to generate evidence that astrology is right. You should be looking for evidence that it's wrong. And to the extent that you can't come up with any, then it's a good theory. So, yeah, there's no evidence that he wasn't born on July 28th, 1902. There's no evidence that he didn't grow up in Vienna. No. Yeah? So, when people tell me, so, I ask, what is science? And people tell you it's about falsification. I don't think most people have this in mind. This is a very radical view. He doesn't think that our theories are ever justified. Yeah? We might use slightly newer philosophical vocabulary. There's this guy, Bas van Fraassen. He's kind of a contemporary philosopher of science. He talks about belief versus acceptance. So Bas van Fraassen thinks it's a Trump's game to don't ever believe your scientific theories. What we do is accept them because they match up with our observations. Yeah? So you say, do you believe quantum mechanics? I say, well, I think it matches all the observations we made. And what extra work does it do to say that I believe that it's true? What do you get out of that you don't get out of, well, no, it fits all of our observations?
Believe it's true, that means you're biased. Like means you have a fundamental bias.
Well, you're kind of locked into it in some sense. Yeah.
Well, I was just gonna say, I don't disagree, but with the whole back to the mRNA theories, it's
Yep.
they only proved it was true because they believed it was true.
Yeah.
And all of their experiments said it was false until they found one that said it was true.
Right.
And then
Right.
now we know it's true.
Yeah. So they're not being good Popperians. Yeah. Yeah. So this is in some sense the tension. That's very good. So this is in some sense the tension between at least Popper's picture of how we should treat scientific theories and how scientists actually treat their theories. So we get a kind of serious disconnect here, don't we? Between scientists don't in general find one piece of disconfirming. Like if you found a piece of copper that wasn't conductive, you don't go, that whole copper's conductive theory, that's out now. You say, probably my instrument doesn't work. Right? You don't just go, well, guess that whole chemistry thing's over then. Right? But anyway, so for Popper, unrefuted theories, they get a kind of special status. Popper he doesn't talk about acceptance, he talks about corroboration. These are all kind of ways of talking about something that you don't think you have no evidence that it's true, but it's nonetheless gets a special kind of place in your worldview because it's been the one that stood up to the tests of disconfirmation the best. Yeah? Okay, so, yeah, again, most people who are quick to answer, falsification, that's what makes something science, don't have all of this package of stuff in mind. And I think that they're pretty deeply connected in their logic. So worth thinking about, I think. Okay, so there's the basic idea. There's Popper's demarcation criterion. Couple questions. Is falsifiability necessary to call something scientific? So string theory, for example. It's really hard to falsify string theory. There's a whole bunch of ways that you can adjust the parameters of string theory, like how many dimensions there are, how are the dimensions related. Some of them are all curled up small and some of them are spread out. You can play with all those variables and get very different predictions to the point where it looks like it's hard to get a prediction that would disconfirm string theory. So does that mean string theory is not science? Some people say yes. Yeah.
Can you have something that's better than science?
It's philosophy. Yeah.
No, I mean, so
I agree. Thank you. Yeah.
So you have something that's so fundamentally true that is just on a level that's beyond science.
I don't know. I don't know a serious answer to that question.
Fair enough.
Okay. Yeah.
Yeah, I guess it makes sense that string theory would be classified as like science as we know it. That doesn't mean it's not like valuable. Like,
Good.
yeah, right. And also like there's a lot of things that we believe a long time ago before science was invented, or before we came up with possible science, and we still use those. We still consider those scientific discoveries. So yeah, like
Good.
Yeah, it doesn't mean it's more or less.
Good. So with string theory in particular, maybe it doesn't count as science yet, but it's a kind of framework where we could look for new scientific theories. So we could look for confirmable, disconfirmable theories within the broad framework of string. String theory, by the way, is one of the hopeful points where we might get quantum mechanics and general relativity together. So remember that to fundamental physics, hopefully very disturbing fact that our two most successful theories are clearly incompatible. One of the appeals of string theory is that you can get them working together. So maybe it's a nice place to look for future science, but isn't itself yet science. Yeah?
It's essentially the same thing that he said, but I was going to say, if you can't observe something, you have to figure out a way to observe something.
Right.
So this is just the way I feel like they're trying to figure out how to observe something.
Right.
And they're going to try to make it scientific.
Good. Yeah. So one of the problems is that to test string theory, to test which of the many strings, is sort of a genre of theory rather than a theory. To test the various string theories, we know what to do. It's just the energy levels you need to get to are so high that, I think I said this before, you need a particle accelerator roughly the size of the orbit of Pluto to test it. And that's hard, but at least it's, so in principle testable is still pretty good, right? You know what observations would test it, even if it's super hard to test. So maybe that helps it become science. Like in principle, we know how to test it. It's just like vastly beyond our technology at the moment. Here's a different one. So Popper recanted this later in his career, but early in his career, he said that the theory of evolution is not science, because essentially it amounts to the following thing that's true by definition: survivors survive. You can't prove that's wrong, because they do. Survivors survive. That's what it means to be a survivor, that you survive. So early in his career, he thought that means that the theory of evolution is not testable. Yeah.
Is that because it's true in and of itself?
So survivors survive, yeah, is just clearly true. So this might be a nice place to keep in mind that he's not saying that things that aren't science aren't valuable. So math and logic, if survivors survive is not science, then 2 + 2 = 4 isn't science either. But Popper's clearly not saying that that's a worthless thing to know, right? There's nothing that you could do to disconfirm 2 + 2 = 4. Any observation is going to match up with that. But that doesn't make basic arithmetic valueless. It just means that it's not part of science. Modern evolutionary theory, by the way, goes vastly beyond survivors survive. It makes all kinds of quite specific predictions. It's constantly changing. It's constantly under development. So there's way, way more to contemporary evolutionary theory, and has been for 150 years or something like that, than just this. So that's, contemporary evolutionary theory escapes this critique entirely. But yeah.
So, like the fundamental statement, survivors survive, is there a term for that? Or is it just a fundamental truth?
Tautology.
Okay.
Yeah, in philosophy, something that's true by definition is called a tautology. Yeah.
Okay.
Yeah. Yeah. Okay. Okay, so let's suppose that it actually is necessary. Is it sufficient? So, for example, I would say that the flat Earth hypothesis is fully falsifiable. Does that mean it's a good scientific hypothesis?
No.
Right. No, because it's wrong. It's that we have falsified it, right? I mean, it's clearly been I hope there's no flat earthers in the room, but like, it's been falsified. If you don't know already, it's been falsified. We've worked this one out. We really tested the heck out of this one. It's a roundish thing. Yeah.
Very psycho, but I find it as well. I'm sorry if there's flat earth. I find it.
They're used to it. It's okay.
I find it very funny to hear some of the justifications that how all other planets are round somehow.
Yeah.
Like our Earth is flat and NASA is fake or something like that.
Yeah, it's an elaborate. But actually, that brings us to an interesting question. So, when a theory and an observation don't match up, what do you do? What do you do when your theory doesn't match your observation? And it's not just the thing that I just told you about falsification really doesn't answer that question. It's a difficult question to answer. So sometimes you can make small adjustments and make so that I take it this is what somebody who's a flat earther does. They make an observation, it doesn't match their theory because it's not flat, and then they just make a small adjustment to their picture of the world. It's like, well, sometimes light curves over lakes because of some diffraction thing. And then so they add what they call an ad hoc hypothesis. So they just sort of make small theoretical adjustments to work the observations into their theory. And I'm making fun of the flat earthers, but real scientists do this too. You get an anomalous observation, and sometimes the really smart thing to do is actually just change some small detail of how you're thinking about the scenario rather than chuck the whole thing out. Now, suppose you're not going to do that. Suppose you're not going to add in an ad hoc hypothesis. Then the question is, how much theory gets falsified? So theories get embedded in theories get embedded in theories. So you find some anomalous observation. You say, well, that's it for chemistry. Our chemistry predicted this, therefore we throw the whole thing out. Or do you say, well, that's it for the solid state chemistry about nickel ions in this solution? Yeah? Like, the Popper's thing does not tell us how much, what chunk of theory should be rejected. It doesn't even really give us guidance. He doesn't say much about that at all. So this is a picture of the web of knowledge. The web of knowledge is, of course, held up by observation. But typically, there's always some adjustment in the theory that you can make to preserve a bunch of it and accommodate the observation. And there's just really difficult questions. I think this is not just questions for Popper, but actual practical questions for science about how far into the theories you should let some anomaly ramify. Like how much theory gets thrown out. Yeah?
Is it just like until it stops becoming the same theory, or is it okay?
I really don't, I'm not being rhetorical, I really don't know the answer to this question.
Or components of the theory be worse than like they need to maintain certain fundamental
Yeah.
aspects of the theory?
Yeah. So these are the kind of questions that Thomas Kuhn's going to deal with. So next week we'll start talking about Thomas Kuhn's theory of paradigms and paradigm shifts. So Kuhn's got this picture where, a theory can tolerate a whole bunch of anomalies. The anomalies kind of build up, and people will often just put them on the shelf and they say, well, we don't have any idea how to deal with this, but the theory's making a whole bunch of good, it's solving a bunch of puzzles. So for Kuhn, the characteristic thing that 99% of science does is solve puzzles. Small scale puzzles, like we talked about Grinnell's stuff on cell adhesion, right? Say, I want to work out what makes a cell adhere to a petri dish or to another cell. And you work out some of the chemical questions about that, and they're relatively like fine-grained questions. All of this is happening in a very stable overall theoretical context. It's what he calls normal science. So 99% of science is normal science. The experiment that I showed you earlier of like, we proved Einstein right and Lorentz wrong, that's a rare exception where we're doing this radical theory change, this falsification of a whole theory, or not. Almost all science is kind of working out relatively small scale puzzles within a paradigm. And so we'll talk about Kuhn next time. Next week we'll start talking about Kuhn and his picture of how anomalies get typically worked into a theory with small adjustments, but that at some point, usually when there's a new theory kind of waiting in the wings, we get a radical overall revolution. So Kuhn's going to bring in some of that descriptive content that I said we were going to leave behind to try to match, how does the history of science look with how should science actually work. Okay, that's enough for today, I would say. Next time we'll talk about Kuhn and paradigms.